So, just to review, we talked about zero pairs. What is the value of this? 4 plus 0 plus 0 plus 0 plus 0. What does that equal? 4. So if I add them or take them away, it doesn't change the value. That's really important for algebra tiles. We use that a lot, even next year when we're doing multiplying and dividing. Opposites are important, okay, so we can add or remove zero pairs at any time. Okay. So opposites, we had a plus 1 and a minus 1. Those are opposites. And we also had opposites of plus x and negative x. And then what was the last type of zero pair? Positive x squared and negative x squared. Okay, so those are the three types. Now you only want to add them if you need to, and that's with subtraction. And you only remove them if they're formed, and usually that's with addition. Okay? So zero pairs is an important concept that comes up quite a bit. So often you're going to see this, collecting like terms. Those are the instructions. It's like you throw everything into a pot right here, mix it up, and of course you want to organize it. Now you guys did that naturally. Did you realize that when you put the tiles down, you put your big squares together, you put your small squares together? Right? You didn't draw a big square here and another one way over there with like a little square here and maybe a little square there. Right? None of you actually grouped like that. You grouped them all similar shapes together. And that's what we're going to do. It's like we're throwing this into a bag, shaky, shaky, shaky. And when we're done, what we're going to do is draw them all together. So there's 3x. Sorry, I screwed that up. Here is 2x squared. We want to draw our big squares together. So degree 2. And there's another x squared. Okay. Then I'll just use a different color to emphasize the difference as the different shapes. Okay. There's 3x. And then the plus 2x. Okay. So all together, what do you have? 3x squared plus 5x. Right? And your coefficients tell you how many there are. It's that simple. Okay. So what I want you to do now is draw the next one. Okay, draw your big squares together, all your rectangles together, and all your small squares together. Group them up as you draw them. Okay. Okay, so I used x squared, one of them, and then over here we have another 2x squareds. We have 2 red x's and then another x, and then we start with negative 2 one tiles, and then we add a negative 3. All together, what do I have? 3x squared plus 3x minus 5. Now what order is that? What do we call that? This is degree 2, degree 2, degree 1, degree 0, descending. Please write it now in ascending order. Write it in ascending order. Question page? So we should have negative 5 plus 3x plus 3x squared. That would be ascending order. It's a leaf blower outside. They're blowing leaves. Yeah. Okay. Hey, any questions about that? Descending, ascending? Just reviewing that. Now, when you group them, what system did you use? Yep. Yep.
Why would you put 5 minus 3x?
Well, how many do you have here? What do you have? -5. How many? And are your x's negatives?
Nope.
That's right. So that's an important point. Keep the same sign. Your coefficient will never lose its sign. Okay. Otherwise, it's like you flip the tiles over. You shouldn't do that for no reason. So how did you group these? Same shapes you group together, and same shapes are like terms. Okay. So the groups are like terms have the same shape. Now what that means is that they have the same letters and the same exponents. Nothing can be different. So that's the definition. What we want to do is see which terms are alike. Please put a box around all the x terms. Go. Put a circle around all the x squared terms. Put a triangle around all the xy terms. And if there's anything else that's alike, just connect them with a line. So you should have a box around the 7x. You should have a circle around 5x squared because those are alike. The xy's, you should have a triangle around it. Did anyone not think they should put a triangle around this? Why? Do you have any different letters? No? Are the exponents exactly the same? Did this person here know his alphabet song? Nope. So someone needs to go back and watch Sesame Street a bit more. Okay? But they're still alike. Okay. Are there any other like terms?
Yes.
What?
Good.
Shh. These are also alike. Okay? Because they both have xy squared. So if someone screws up and doesn't write alphabetically, you have to be smart enough to know, hey, you know what? This person really should have went 8xy squared. Okay? That's a better way of writing it because it's alphabetical. That's not the end of the world. Yep.
What about the 4xy? Like 4x.
Do you see anything else with an x squared y? Do you? Yeah, this one is completely different than all the rest. Yep, so it is unlike. Okay. Sarah? What's the letter? And the exponent? What's the letter? Exponent? What's right? So you gotta be super careful, right? But you just gotta look careful, okay? So an example of unlike terms, this would be like if we have 2 dogs plus 3 cats. If we combine them together, what do we get? That's right. 2 dogs plus 3 cats. You're not some freako scientist trying to make a cat dog. Okay? So, if Tim has 2 oranges, 2 apples, I have 2 oranges, 2 apples. How many do we have altogether? 4 oranges, 4 apples. Okay? We do not make an apple orange. There's no apple oranges. Okay? So, example of unlike terms, 3x squared plus 2x, 4y plus 7x. Okay, so different exponents or different letters, or both. Right? So, what we're doing now is a little bit harder work. What I want you to draw is I want you to draw these and match them up. So draw 3x, then draw a negative x, and I know it's negative because I shaded it in. I just used a different color to show you that it's different than the other 3x's. Draw a negative 3, and then draw 5 positives. And I'm drawing them, pairing them up for a reason. What happens when you pair up two opposites? Yeah, they make 0, they cancel each other out. So you should actually circle it, and if you had your pieces, you can remove it, but since you don't have your pieces, just cross it off. Same with the next one. They pair up, and what value do they make when they pair up? No. What value do these 6, yeah, they make 0. Cross them off. What's left over? Good. Make sure you draw this exact. This isn't little guesswork, make it up on your own. Draw it exact or mark it exactly wrong. That's your math joke for the day, folks. Okay. Next one, go ahead. Draw your x squareds. What do you want to draw next? Yeah, draw the x's. Put them in a good order, right? Okay. Okay. Remove any 0 pairs you can. No, the blue is just the first shape I drew. The red is the second shape. Shading and non-shading is making it positive or negative. Okay. It's just so you can see the different pieces.
Okay.
No, that's good to ask. Always do, okay? So 0 pair removed, 0 pair removed, and no other 0 pairs. What do we have when we're all done? Tony? What do we have? What is this one? Good. How many? Good. We usually just don't write the 1. No worries, but we always do say it. And what else? How many? Awesome. Good job, Tony. And the last one. Well, these are all negative 1s. And how many are there? Well, each one is negative 1, so, and there's 5. So it'll be negative 5 altogether. Okay, good job. Okay, now I want you to change that. Please write that in ascending order. This is descending, right? Degree 2, degree 1, degree 0. So ascending order is degree 0, degree 1, degree 2. Okay. So how can we do this without tiles? Without drawing? Yep. Add what though? What do you mean by them? What's that key word? The shape? Thank you. Okay, so what we want to do then is add or subtract, depending on their sign, coefficients. So, let's start with our x squareds. There's plus 4, here's plus 10. Whoops, plus 5. Almost screwed that up. How many altogether?
4.
4 and 5? 9x squareds. On our x's, here's plus 6, here's plus 10. How many altogether? And the last one, we have a negative 2 and negative 7. Negative 9. We just put them together. Okay, try the next one by yourself. Go. How many x squareds? Negative 6x squareds. You know what Mr. Barker likes to do when he adds them together? Yeah. Here's part. Always look at the sign in front. Here's plus 4 and here's minus 10.
Oh, I got it. Yeah, okay.
Okay. So always watch the sign in front. How many x's? Negative 2. And how many 1 tiles? Plus 4. Wrong. Negative 3 minus plus 8 is 5. Plus 7? Plus 12. What's the order called? Degree 2, degree 1, degree 0? Please write in ascending order. Change the order, please. Write in ascending. So it should be 12 minus 2x minus 6x squared. Always keep the sign with the coefficient. Okay. Do example 7. Different letter. Not much changes though. Look at your coefficients. How many d squareds? Miranda? Good. How many d's? Dustin? Yep. How many 1 tiles? Tiction? 10. How many people got that? Hands up.
I got it.
Awesome. You guys are experts. 8's challenging. I hope you were listening. Do number 8 now. Okay. So, how many x squared terms are there? 5. You know what you guys can do so you don't miscount? Cross them out. Okay, 5x squareds. How many y squareds? 1. So we don't write the 1. We just write y squared to show that there's 1 there. What if there were 0 y squareds? What would you do? Don't write anything. How many x squared y's are there? These are the exact same. Just because someone doesn't write them in alphabetical order doesn't mean you can't combine them. It just means they don't know their ABCs. Okay. Good. Okay, what I want you to do real quick here is I want you to find the perimeter. Go. Please do it on that side as well if you can. Okay, right, you can work on the left side. Add up all the sides. Don't use a calculator. 5 plus 3 is 8. Plus 4 is 12. plus 5 is 17. Plus 6, that's the hard one.
I lost count.
23.
Oh, 23. Is it 23?
Isn't it?
Oh, yeah.
23x minus 6. Good. Add up all the sides. Now I'm going to say x equals 10. Find the perimeter, please. Start by writing out the formula, then substituting in, then solving. Go.
Wait.
Sorry, kids. Okay, your homework is listed on your outline. Pitter patter, get at her. Go. I put all the algebra tiles away, but if you want to use them, like keep them on your desk. If you want to use them, you can, but you don't have to. Just try not to lose them. Because that